So next we have some word problems involving linear inequalities. This is number 21. Ravi got 70 and 75 marks in the first two unit tests. We have to find the minimum marks he should get in the third one so that his average becomes at least 60 marks. So we first let that Ravi get X marks in the third test. That's how we start the solution. Then the average of the marks he got in the three tests will be 70 plus 75 plus X divided by 3. This average should be at least 60 marks. That means this should be greater than or equal to 60. And now we solve this inequality for X. So the first step you can do is you multiply both sides by 3. That will not change the direction of the inequality because 3 is a positive real number. So 3 times 60 is 180 and simultaneously 70 plus 75 is 145. And then you subtract 145 from both sides, and that way there will no longer be 145 on this side, and on this side you will have minus 145. So 180 minus 145 becomes 35. So X should be at least 35 so that the average is at least 60. Next, number 22. To get A grade in a course, one must get an average of at least 90 marks in 5 examinations, each of which has 100 marks. If Sunita secured these marks in the first 4 exams, which are respectively 87, 92, 94 and 95, then what should her mark in the 5th one be so that she can get A grade? At least, there should be a minimum mark that she should get in the 5th exam so that she can secure A grade. So the solution is similar to the previous one. Let Sunita get X marks in the 5th exam. Then the average of all her marks in the 5 examinations is this: 87 plus 92 plus 94 plus 95 plus X divided by 5. In order to get A grade, this has to be greater than or equal to 90. Now I am not going to solve this like the previous one for you. I am leaving that to you, but I will tell you what the answer is. And the answer is this. This is true if and only if X is greater than or equal to 82. So Sunita should get at least 82 marks in the 5th exam so that she can get grade A. Otherwise she cannot get grade A. Next, number 23. Find all pairs of consecutive odd positive integers. Not just consecutive integers, consecutive odd positive integers, where both means in a pair there will be 2 numbers. Both of those numbers are smaller than 10, but their sum is larger than 11. So we start the solution like this. Let a required pair be this. We have written A here, not D, because we don't know how many such pairs are there. There may be more than one. This is one such pair. We have written it as an ordered pair. If you want, you can write it as a set also. Nothing essentially will change. It consists of these 2 numbers, 2n plus 1 and 2n plus 3. Why? Why do they look like this? Because the numbers have to be odd. That is why if one of them assumes this form 2n plus 1, then the other one should be consecutive. So the next one will be 2n plus 3 obtained by adding 2 to it. But why does the number look like this in the first place, 2n plus 1? That is because it's odd. And that's why you have to also mention what n is, where n is a non-negative integer. You have to also keep in mind that the numbers have to be positive. So if n is non-negative means n can be either positive or 0. If n is 0, you are getting 1. Okay. And by considering the other positive options for n, you get the other odd numbers. For example, if you take n equal to 1, you get 3 here. For the choice n equal to 2, you get 5. So like that the numbers go. If n is 0, this is 1, this is 3. If n is 2, then this is 3, this is 5, like that. the pattern goes. So if this is such a pair, then what other conditions are imposed on this? That both the numbers have to be smaller than 10. That is 2n plus 1 is less than 10 and 2n plus 3 is also less than 10. And also their sum is more than 11. Now we have to solve these inequalities and find what the pair is, or maybe there are more pairs, we have to find all of them. We first take this inequality 2n plus 3 less than 10 and solve it. So the first step of course is to subtract 3 from both sides. That will make the left hand side 2n and the right hand side 10 minus 3, which is 7. And then you divide both sides by 2. Because 2 is positive, the inequality retains its direction. And you get n less than 7 divided by 2. And simultaneously we also take this one, which if you do the sum on the left hand side, it becomes 4n plus 4. That is greater than 11. So then in the next step you subtract 4 from both sides, making the left hand side 4n and the right hand side 11 minus 4. And now we are going to continue. So in the next step this becomes 7, right? 11 minus 4 is 7. And then we divide both sides by 4, this time obtaining n greater than 7 divided by 4. So n is simultaneously greater than 7 divided by 4 and less than 7 divided by 2. If you are wondering why we did not do anything about this first inequality, that is because if 2n plus 3 is less than 10, then 2n plus 1 is automatically less than 10. That's because 2n plus 3 itself is greater than 2n plus 1. Now from these inequalities, some values of n will come out. Do not forget that n is a non-negative integer. So n is not a real number that you can take any value for n between these two real numbers. N is a non-negative integer, and because of that there will only be finitely many options for n. And there are only two such integers which lie in this range between these two numbers, and they are 2 and 3. So n can be either 2 or 3. When n is 2, then what is the number 2n plus 1? That is 5. And the next consecutive odd number is 7. So one of the pairs is 5, 7. And when n is 3, then 2n plus 1 is 7 and the next one is 9. So the other pair is 7, 9. You can see for yourself that in both the pairs, both the numbers are less than 10, but their sum is greater than 11. This next one, 24, is similar, but this time we have to find all pairs of consecutive even positive integers, where both the numbers in a pair are larger than 5 and their sum is less than 23. So the formulation of the solution is also similar, but be careful to really formulate it properly. It's not exactly the same as the previous one. This time let a required pair be 2n, 2n plus 2. Because the numbers have to be even, so they have to both be divisible by 2. So they will normally be of this form 2 times some integer. Let one of the numbers be 2n, then the next consecutive even one is 2n plus 2. But what is n? The numbers also have to be positive. This time you cannot start with the value n equal to 0, because then 2n would be 0, that is not positive. So n itself has to be a positive integer. And the numbers should both be in a pair. They should both be larger than 5 and their sum has to be less than 23. I am leaving the task of solving these inequalities to you. Proceed as in the previous solution, and these are the 3 pairs you should get: 6, 8, 8, 10 and 10, 12. Here you can see that in each pair both the numbers are larger than 5 but their sum is less than 23. Number 25. The longest side of a triangle is 3 times the shortest side, and the third side, other than these two there is also another side, that is the third side, is 2 centimeters shorter than the longest side. if the perimeter of the triangle is at least 61 centimeter, perimeter is the sum of the three side lengths, then find the minimum length of the shortest side. Let the shortest side be of length x centimeter. It's given that the longest one has length 3 times the shortest one. That means then the length of the longest side will be 3x centimeter, and the third side is 2 centimeter shorter than the longest side. That means its length will be 3x minus 2 centimeter. And now what is given to us? That if the perimeter is at least 61 centimeter, then we have to find the minimum length of the shortest side. So we get this inequality if we express that last condition mathematically. The perimeter is the sum of the three side lengths, x plus 3x plus 3x minus 2. That has to be at least 61. So it's greater than or equal to 61. Now let's solve this inequality. 3x plus 3x is 6x, 6x plus x is 7x. 7x minus 2 is at least 61. Then you add 2 to both sides and get 63 on the right hand side. And then you divide both sides by 7. 63 divided by 7 is 9. So that means the length of the shortest side has to be at least 9 centimeter for this to happen. So you can write the final line yourself, that the minimum length of the shortest side has to be 9 centimeter. And finally we have number 26. A man wants to cut 3 lengths from a single piece of board of wood, and that board has length 91 centimeter, and these are the conditions. The second length has to be 3 centimeter longer than the shortest. There will be one having shortest length. The second length means the next larger one has to be 3 centimeter longer than the shortest length, and the third length, which will be the largest, is to be twice as long as the shortest. Now what are the possible lengths of the shortest board? Of the shortest board only, okay, not the other ones. I mean, of course, automatically you will get the other lengths also if you find the shortest one because of these conditions. But what are the possible lengths of the shortest board if the third piece is to be at least 5 centimeter longer than the second? So this final condition is also given. Now I am going to neither formulate nor solve this problem for you. You do it yourself and write in the comment section below. Let's see what you come up with.